Today's lab consists of two main parts. In the first part, you will prepare a standard curve by using concentrations such that the reaction goes to completion. In the second part, you will use concentrations that will stop at equilibrium. Using the data you gathered in part 1, you will be able to calculate the concentration of each component at equilibrium. Today's lab will be using spectroscopy to determine concentration. You will shine light through your sample, and a detector will determine how much light and at what wavelength is being absorbed by your sample. The higher the concentration of colored species, the more light will be absorbed. For part 1, you will prepare 5 beakers with varying amounts of iron nitrate and thiocyanate. In part 1, it is important that you use the 0.200 molar iron nitrate. Since it is much more concentrated than the thiocyanate, we will assume that all of the thiocyanate will react, hence the reaction going to completion. Use the table in your lab to be sure that you are preparing your beakers correctly, and note that each one should total 50 milliliters at the end. The best procedure is to mix the water and iron nitrate for each beaker in advance, but wait to add the thiocyanate until right before you are ready to collect your spectrum. Also, it does not really matter what size of beaker you use, so if you can't find 5 100 milliliter beakers, be creative. To calibrate the spectrometer, obtain a cuvette and use a pipette to fill it about 3/4 full of your blank solution, which is labeled Beaker 1. Be careful to hold the sides of the cuvette only, as fingerprints can absorb light and skew your sample. To remove any fingerprints or water drips, you should wipe down the cuvette with a Kim wipe before you place it in the spectrometer. A Kim wipe is a lint-free tissue. Do not use a regular paper towel, which can leave lint behind and even scratch your cuvette. If you see any air bubbles in your sample, you should dislodge those by tapping your cuvette on the table, as air bubbles will absorb light differently than your liquid sample. Once your sample is in the spectrometer, on the computer choose Experiment, Calibrate, Spectrometer. After the 90-second warm-up is complete, you will see an option to finish calibration and then OK. After your calibration is complete, you can dump your blank into a large beaker that will serve as your waste beaker throughout the experiment. Now add the prescribed amount of thiocyanate to beaker 2 and swirl to combine. Place a small amount of thiocyanate in your cuvette, swirl it, and dump it into your waste beaker. Repeat one more time. This is a way of cleaning something that will not be easy to dry. So now if there are any droplets inside your cuvette, they are of your beaker 2 solution, not your beaker 1 solution. After 2 rinses, fill your cuvette 3/4 of the way full with beaker 2 solution and place it in the spectrometer. Hit collect. At this point, it is measuring every wavelength, and we only are interested in the wavelength that is absorbing most. So now we will choose Configure Spectrometer and choose Absorbance versus Concentration. It's going to pick the wavelength where it's absorbing the most and only look at that absorbance from now on. Okay, now choose Collect, and when it becomes available, choose Keep. The software will prompt you to input the concentration. You calculated this in your pre-lab. So put in the concentration for beaker 2. Do not hit stop. Discard your solution and complete your beaker 3 by adding the thiocyanate. Rinse your cuvette with beaker 3 solution, fill it with beaker 3 solution, place it in the spectrometer, and hit keep again. Again, it will ask you for your concentration. This time put the concentration for beaker 3. Again, you're not hitting stop in between. So continue to do that for each solution, hitting keep after each one. Now once you finish all your beakers, you can hit stop, and now you should choose the linear fit button. Write down the equation of the line that you are given. This is the relationship between how much light is absorbed, which is what's called Y here, and the concentration of your iron thiocyanate product, which is called X here. Now you're finished with your standard curve and you're ready to complete the equilibrium portion of this lab. For this part, you will repeat the procedure from part 1, but with the test tube volumes given to you in part 2. You're only making 10 milliliters of solution in part 2. Also note that you will be using the 0.00200 molar concentration of iron this time, and this low concentration is what will ensure you reach equilibrium instead of completion. For each test tube, you will measure the absorbance as you did in part 1. However, you won't be doing the collect and then keep thing this time because you don't know the concentration. Instead, you will just write down the absorbance of each test tube. You will need to hit collect in order for the absorbance to update in real time. You can choose append to latest or store latest run if those options come up, but what you should see then is the absorbance in your lower left hand corner, and it should change if you pick your sample up and down. So record your absorbance and then repeat for all of your test tubes. Once you've recorded the absorbance for each test tube, now you can hit stop and then choose Analyze and Interpolate on the menu. And now you should see a box pop up that will correlate your absorbance with your concentration. And you can just move your cursor along the graph until you find the absorbances that you wrote down, and the computer will tell you what concentrations those correspond to, and you can record those as well. Once you're done with all of that, you can place all of the waste that you've collected in your waste beaker in the waste container.